Baking millions of cakes every day sounds impossible. But inside the world's largest cake factories, it happens at an unbelievable scale. With high-speed mixers and precision ovens, these facilities churn out perfectly baked cakes in mere seconds. In this documentary, we take you inside massive cake factories that transform raw ingredients into sweet perfection at lightning speed. Cake production begins with the selection and sourcing of high-quality raw ingredients. Flour is the primary component, usually made from wheat, and it is carefully milled to achieve the right texture and protein content for cake production. Sugar is another crucial ingredient, providing sweetness and structure to the cake batter. Granulated sugar, powdered sugar, and sometimes liquid glucose are used depending on the specific type of cake being manufactured. Eggs, either fresh or in liquid or powdered form, contribute to the structure and moisture of the cake. Dairy ingredients such as butter, milk, and cream enhance the flavor and texture. Vegetable oils, often used as a substitute for butter in large-scale production, ensure a longer shelf life and a softer crumb. Leavening agents such as baking powder or baking soda are essential to create the airy texture that defines a good cake. Flavoring agents including vanilla extract, cocoa powder, fruit purees, and artificial flavors are precisely measured and incorporated to achieve consistent taste profiles. Before production begins, the factory undergoes rigorous sanitation procedures to ensure a clean environment. Production lines, mixers, conveyors, and baking equipment are all sterilized to prevent contamination. The ingredients are stored in temperature-controlled silos or containers, with automated systems regulating their dispensation. Large-scale cake production begins with precise ingredient measurement. Factories utilize automated weighing systems that ensure every batch maintains the correct proportions. Dry ingredients like flour, sugar, and leavening agents are sifted and aerated to remove clumps before entering the mixing phase. Liquid ingredients such as eggs, milk, and oils are stored in large tanks and piped directly into the mixing units. Mixing is a critical step in cake production, requiring advanced industrial mixers that can handle large volumes while maintaining consistency. The process varies depending on the type of cake being produced. Sponge cakes require aeration to create a light texture, while denser cakes need thorough mixing to ensure a uniform crumb. Continuous batter mixing systems operate at high speeds, gradually incorporating the ingredients in precise sequences. Some factories use planetary mixers, which rotate on multiple axes to create an even distribution of ingredients. Ribbon blenders or high shear mixers may also be used to emulsify fat-based batters. Mixing times and speeds are carefully programmed to avoid overmixing, which can result in tough cakes. Once the batter reaches the desired consistency, it is transferred through a network of pipes or conveyor belts to the depositing machines. These machines portion the batter into molds, trays, or baking pans, ensuring uniformity in weight and shape. Modern cake factories employ volumetric or piston-based depositors that release precise amounts of batter with each cycle. Some machines are equipped with multiple nozzles to fill several trays simultaneously, increasing efficiency. At this stage, additional ingredients such as fruit pieces, nuts, or chocolate chips may be incorporated, either mixed into the batter or sprinkled on top before baking. The filled molds or trays move along a conveyor system into industrial ovens. The baking process is meticulously controlled to achieve the desired texture and color. Tunnel ovens, rack ovens, and convection ovens are commonly used in large-scale cake production. Tunnel ovens, which feature continuous conveyor belts that move cakes through different temperature zones, ensure even baking. The temperature and humidity levels within the ovens are carefully regulated to promote consistent rising and moisture retention. During baking, leavening agents react with heat to create gas bubbles, causing the batter to expand. The Maillard reaction, A chemical process between amino acids and sugars develops the golden brown crust and enhances flavor. After baking, the cakes must be cooled to prevent condensation and sogginess. Cooling tunnels equipped with controlled airflow rapidly bring down the temperature while preventing excessive moisture loss. The cooling process is crucial because cakes that are too warm can compromise the integrity of icing or packaging. Factories often employ spiral cooling conveyors that maximize space efficiency while allowing cakes to cool gradually. Some facilities use blast coolers that rapidly reduce temperatures without affecting texture. Once sufficiently cooled, cakes may be removed from their molds using automated depanning systems. These machines use gentle vibrations, air pressure, or mechanical arms to lift cakes without damaging their shape. Before proceeding to decoration, quality control checks are performed. Cakes are inspected for uniformity in size, shape, and color. Advanced vision inspection systems use cameras and sensors to detect defects such as uneven surfaces or air pockets. Weight sensors ensure each cake meets the required specifications. Any cakes that do not pass quality checks are either reworked or discarded. Some factories employ metal detectors and X-ray scanners to identify foreign objects or contaminants. The decoration process varies depending on the type of cake being produced. For layer cakes, automated slicing machines cut the cakes horizontally to create multiple layers. These layers are then conveyed to filling stations, where robotic arms or extrusion nozzles apply cream, fruit preserves, or ganache. In some cases, conveyor systems transport the cakes through enrobing machines, which coat them in a layer of chocolate or glaze. Icing and frosting are applied using precision nozzles, spatula robots, or rotary icing machines. Buttercream, fondant, or whipped cream is spread evenly across the surface. Some factories use airbrush systems to add gradients of color or decorative effects. For cakes that require intricate designs, programmable robotic arms pipe decorative elements with incredible precision. Sprinkles, chocolate shavings, or edible glitter may be added using automated dispensers. At this stage, cakes intended for retail packaging may be pre-sliced using ultrasonic cutting machines. These machines utilize high-frequency vibrations to create clean, precise cuts without crushing the delicate cake structure. Pre-sliced cakes are often packaged in individual portions for convenience. Cakes intended for long shelf life may undergo additional processes such as modified atmosphere packaging, which removes oxygen from the packaging to slow down spoilage. Packaging is a crucial step in maintaining product freshness and ensuring a visually appealing presentation. Cakes are carefully transferred onto packaging conveyors, where they are placed into plastic trays, paperboard cartons, or clamshell containers. Flow wrapping machines seal individual cakes in airtight film to extend shelf life. For larger cakes, shrink wrapping or rigid plastic domes provide protection during transportation. Labels with product information, barcodes, and expiration dates are applied using automated labeling machines. Before distribution, final quality control checks are performed. Cakes are weighed again to confirm portion accuracy. Some factories conduct random sampling to test for taste, texture, and moisture content. Microbiological testing may be carried out in on-site laboratories to ensure food safety compliance. Cakes are then organized into cartons or crates and palletized for transportation. Temperature-controlled storage areas maintain product freshness before shipment. Depending on distribution requirements, cakes may be transported in refrigerated trucks to prevent spoilage. Large-scale manufacturers distribute cakes to supermarkets, bakeries, and retailers across vast geographical areas. Once the cakes are packed and ready for distribution, they move through a final inspection stage to ensure that packaging integrity is maintained. Automated vision inspection systems scan the packaging for any defects, such as improper sealing, misaligned labels, or damage that could compromise product quality. Any faulty packages are removed from the production line to prevent them from reaching consumers. At this stage, lot numbers and expiration dates are printed onto the packaging using high-speed inkjet printers or laser etching machines, allowing for precise tracking and traceability. This is a critical aspect of food safety regulations, as it enables quick recalls in the unlikely event of contamination or quality issues. Once the cakes have passed all final quality control checks, they are transported to cold storage or distribution centers. Cakes that require refrigeration, such as those with fresh cream or perishable fillings, are stored in temperature-controlled environments to maintain freshness. These storage areas are monitored by advanced refrigeration systems that maintain optimal humidity and temperature levels. Cakes that have been designed for longer shelf life, such as those using modified atmosphere packaging or preservatives, may be stored at ambient temperatures before shipping. Distribution logistics are carefully planned to ensure that cakes reach their destination in perfect condition. Large-scale cake manufacturers work with refrigerated trucking fleets and logistics providers to manage transportation efficiently. Cakes are loaded onto pallets and organized based on their destination, with detailed inventory tracking ensuring that products arrive at the correct locations. In some cases, cakes are shipped directly to supermarkets, bakeries, or food service providers, while others are sent to central warehouses for further distribution. To minimize damage during transit, cakes are packed in sturdy shipping containers designed to absorb vibrations and prevent movement inside the truck. Upon arrival at their final destination, cakes are unpacked and stocked on store shelves or refrigerated display cases. Retailers follow strict storage guidelines to maintain freshness, ensuring that temperature-sensitive cakes are kept in chilled conditions and that all products are rotated based on their expiration dates. Many cakes are sold in pre-packaged formats, while others are displayed in bakery sections where customers can purchase whole cakes or slices. Supermarkets and bakery chains often use just-in-time inventory management systems to minimize waste and ensure a steady supply of fresh cakes. While the majority of factory-made cakes are mass-produced for supermarkets and retail stores, some facilities specialize in producing cakes for commercial bakeries, restaurants, and catering businesses. These cakes are often supplied in bulk, either as frozen cakes that can be thawed and decorated on site, or as partially finished products that can be customized before serving. This flexibility allows bakeries and food service providers to offer fresh cakes without the need for extensive in-house baking operations. The industrial cake making process has evolved significantly over the years, incorporating advanced automation, robotics, and data-driven quality control systems to improve efficiency and consistency. Modern factories utilize artificial intelligence and machine learning to analyze production data, predict maintenance needs, and optimize ingredient usage. Automated production lines can run continuously with minimal human intervention, reducing labor costs and increasing output capacity. One of the most significant innovations in large-scale cake production is the development of high-speed depositing and baking systems. Traditional cake production required separate steps for mixing, portioning, and baking, but modern inline systems integrate these processes seamlessly. For example, continuous mixing systems automatically adjust ingredient ratios based on real-time monitoring, ensuring that each batch maintains the perfect consistency. Depositing machines equipped with servo-driven technology can rapidly change portion sizes, allowing for the production of different cake varieties on the same production line. Baking technology has also advanced, with energy-efficient ovens that use infrared heating and precision airflow systems to achieve uniform baking. These ovens are designed to minimize heat loss, reducing energy consumption while maintaining consistent product quality. Some modern bakeries use hybrid ovens that combine conventional and microwave heating to speed up the baking process without compromising texture. In addition to traditional cakes, Many factories produce specialty cakes that cater to specific dietary needs and preferences. Gluten-free cakes, for example, require dedicated production lines to prevent cross-contamination with wheat flour. These cakes use alternative flours, such as rice flour, almond flour, or tapioca starch, along with modified stabilizers to achieve the desired texture. Similarly, vegan cakes are made without eggs or dairy, relying on plant-based substitutes such as flaxseed, aquafaba, and non-dairy milk. Sugar-free and low-carb cakes are also growing in popularity, utilizing sugar alcohols or natural sweeteners like stevia to replace traditional sugar. The rise of personalized and custom cakes has led some factories to develop on-demand printing and decoration technologies. Edible ink printers can create intricate designs, logos, or images directly onto cake surfaces, making them ideal for special occasions or corporate branding. Robotic decorators equipped with artificial intelligence can replicate complex piping patterns, allowing for mass customization with minimal human intervention. Some facilities even offer direct-to-consumer cake ordering services where customers can customize flavors, fillings, and decorations before the cake is produced and shipped. Despite the high level of automation in modern cake production, human oversight remains essential to ensure quality and address any potential issues that arise during manufacturing. Skilled food technologists and quality assurance teams continuously monitor production parameters, conduct taste tests, and refine recipes to maintain consistency. Regular equipment maintenance and cleaning schedules are strictly followed to prevent contamination and ensure compliance with food safety standards. Sustainability is an increasing focus in the cake manufacturing industry, with many companies adopting eco-friendly practices to reduce their environmental impact. Ingredient sourcing has shifted towards sustainable palm oil, fair trade cocoa, and locally sourced dairy to support ethical farming practices. Factories are also investing in waste reduction strategies, such as repurposing cake scraps into secondary products like cake pops, or repackaging unsold cakes into discount bakery items. Some manufacturers have implemented water recycling systems and energy-efficient lighting to further minimize their carbon footprint. Packaging innovation is another area of focus, with a shift toward biodegradable and recyclable materials. Traditional plastic cake containers are being replaced with compostable trays, paper-based wraps, and plant-derived biofilms that maintain freshness while reducing plastic waste. Smart packaging solutions, such as freshness indicating labels and QR codes that provide traceability information, are also being explored to enhance the consumer experience. The demand for factory-made cakes continues to grow globally, driven by changing consumer lifestyles, convenience, and the increasing popularity of ready-to-eat desserts. Emerging markets are seeing a surge in industrial cake production as urbanization and income growth lead to higher demand for packaged bakery products. In response, cake manufacturers are expanding their production capacity, investing in new facilities, and adapting their offerings to regional taste preferences. The future of cake manufacturing is expected to see even greater advancements in automation, customization, and sustainability. 3D food printing technology is being explored as a potential innovation that could revolutionize cake decoration and design. AI-driven recipe development could allow manufacturers to create entirely new flavor profiles based on consumer preferences and sensory data. As consumer awareness of health and nutrition grows, factories may develop functional cakes fortified with protein, fiber, or probiotics to cater to evolving dietary trends. One of the most crucial aspects of large-scale cake manufacturing is maintaining absolute consistency across every batch. Consumers expect the same taste, texture, and appearance every time they purchase a cake from a particular brand, and this requires precise control over every stage of production. Factories employ automated recipe management systems that digitally store exact formulations, ingredient ratios, and process parameters. These systems interface directly with mixing and processing equipment, ensuring that every batch is prepared with the same level of precision. Advanced sensors monitor temperature, humidity, and ingredient dispersion, automatically adjusting machine settings if any deviations are detected. Mixing remains one of the most technologically advanced steps in the industrial cake production process. Continuous mixers, which operate non-stop to produce an unbroken stream of batter, have revolutionized large-scale baking. These machines ensure that ingredients are thoroughly combined without overworking the batter, preserving the delicate structure needed for cakes. In some cases, aeration systems introduce controlled amounts of air into the batter to achieve specific textures. The density and fluffiness of sponge cakes, for instance, depend on the precise incorporation of air during mixing. Factories may also use vacuum mixing technology to remove excess air bubbles and prevent inconsistencies. Once the batter is perfectly blended, it is transferred through high-speed piping systems to the depositing stations. These machines dispense exact portions of batter into baking molds, trays, or individual paper cups for cupcakes. The speed and precision of depositing machines play a critical role in maintaining efficiency, as even a small miscalculation in portioning can lead to product defects or waste. Some depositors use volumetric control, ensuring each mold receives an identical amount of batter, while others rely on piston-driven mechanisms to regulate flow. Factories that produce multiple cake varieties may use multi-head depositing machines capable of filling different molds simultaneously. At this stage, additional mix-ins or toppings may be incorporated. Fruit pieces, chocolate chips, or nuts are often added either before or after depositing, depending on the desired distribution within the cake. Some factories use automated dispensing units that sprinkle toppings evenly across the surface, while others employ injection systems that insert fillings into the center of the cake batter before baking. These injection methods are commonly used for filled cupcakes or specialty cakes with jam, custard, or chocolate centers. The baking process itself is highly controlled, with industrial ovens engineered to ensure even heat distribution. Tunnel ovens, which operate on a conveyor belt system, are the most commonly used in large-scale cake manufacturing. These ovens feature multiple temperature zones that gradually heat the cakes as they move through the baking chamber. The initial phase of baking involves rapid heat transfer to activate leavening agents and promote expansion. As the cakes progress through the oven, moisture is gradually released, setting the structure while maintaining softness. Humidity control is a critical factor in industrial baking. Cakes that lose too much moisture too quickly may become dry, while excess humidity can lead to underbaking or structural collapse. Factories use steam injection systems within ovens to maintain optimal baking conditions. Convection fans circulate hot air evenly, preventing hot spots and ensuring consistent coloration. Some advanced ovens incorporate infrared or microwave-assisted heating to accelerate baking times without compromising quality. Once the cakes emerge from the ovens, they must be cooled carefully to avoid textural inconsistencies. Cooling conveyors transport cakes through controlled environments where temperature and airflow are meticulously regulated. Spiral cooling systems, which maximize space efficiency by stacking conveyors in a vertical spiral, allow for gradual cooling while optimizing factory floor space. Some manufacturers use rapid cooling tunnels equipped with gentle air currents to quickly stabilize cakes intended for immediate packaging. At this stage, cakes may be trimmed, shaped, or portioned according to product specifications. High-speed ultrasonic slicing machines are used for precision cutting, ensuring that each slice maintains a clean edge without crumbling. For layer cakes, industrial slicers divide cakes horizontally, preparing them for filling and stacking. Cakes that require shaping, such as sheet cakes for pre-cut squares, are passed through automated cutting systems that use rotating blades or water jet technology for perfect uniformity. The decoration process is where cakes truly come to life, transforming from simple baked goods into visually appealing products ready for the market. Large-scale factories utilize a combination of robotic systems, automated icing machines, and human decorators for final touches. Buttercream, fondant, or chocolate coatings are applied using enrobing machines or precision icing nozzles. Rotary icing machines create smooth, consistent layers of frosting, while airbrush systems add gradients of color for a professional finish. For cakes requiring intricate designs, robotic decorators equipped with multi-axis arms can replicate complex piping patterns, flowers, or lettering with remarkable accuracy. These machines are programmed to follow specific designs stored in digital templates, allowing manufacturers to mass-produce cakes with customized elements. Some factories use edible ink printers to apply high-resolution images or logos onto cake surfaces, a popular technique for themed birthday cakes and corporate branding. Toppings and embellishments such as sprinkles, chocolate curls, or fruit slices are applied using automated dispensers. Some cakes may pass through a drizzling station where thin streams of chocolate or caramel are added for decorative effect. Cakes requiring additional layers of decoration, such as fondant appliques or edible figurines, are assembled by skilled workers in specialized decoration zones within the factory. Final quality control checks are conducted before packaging. Cakes are inspected for uniformity in shape, frosting consistency, and overall presentation. Some factories employ X-ray scanners and metal detectors to identify potential contaminants or foreign objects within the cakes. Weight sensors verify that each cake meets precise product specifications, and random sampling is conducted for taste testing and texture analysis. Packaging plays a vital role in preserving cake freshness and ensuring product protection during transportation. Depending on the type of cake, various packaging methods are employed. Flow wrapping machines encase individual cakes in airtight plastic film, extending shelf life by preventing exposure to air and moisture. Larger cakes may be placed in rigid plastic containers or cardboard boxes with clear windows for visual appeal. For frozen or refrigerated cakes, vacuum-sealed packaging is often used to lock in freshness. Modified atmosphere packaging, which replaces oxygen with nitrogen or carbon dioxide, helps prevent mold growth and extends shelf stability. Cakes destined for international markets may undergo additional protective measures, such as temperature-controlled shipping containers or specialized packaging to prevent movement during transit. Once packaged, cakes are palletized and loaded onto distribution trucks. Logistics teams coordinate shipments to ensure that products reach their destinations promptly. Some manufacturers supply cakes directly to retail stores, while others distribute them through central warehouses for regional distribution. Refrigerated transport is essential for cakes with perishable ingredients, while shelf-stable varieties are transported under standard conditions. The journey of a cake from the factory to the consumer's table is a testament to the efficiency and precision of modern food manufacturing. The combination of automation, rigorous quality control, and advanced baking technologies ensures that every cake maintains the same high standard of taste and appearance. As consumer preferences evolve, factories continue to innovate, developing new flavors, healthier alternatives, and environmentally sustainable production methods. As cakes leave the factory and make their way to retail stores, bakeries, and food service providers, a highly efficient distribution network ensures that they arrive in perfect condition. Logistics teams work closely with transportation providers to maintain strict temperature controls for cakes that require refrigeration. Cold chain management is essential for ensuring that cakes with fresh cream, custard, or perishable fillings remain safe and retain their intended texture. Refrigerated trucks are equipped with sensors that monitor temperature and humidity levels throughout the journey. providing real-time data to ensure compliance with food safety regulations. For cakes that are shelf-stable, such as packaged sponge cakes, pound cakes, or snack cakes, transportation is more flexible. These products are typically stacked in cartons and palletized to maximize space efficiency. Distribution centers receive shipments and sort cakes based on their final destinations, whether they are headed to supermarkets, convenience stores, or wholesale suppliers. In some cases, cakes are sent to intermediary facilities where additional labeling, repackaging, or regional customization takes place before reaching store shelves. Retailers follow strict inventory management practices to ensure that cakes are sold within their optimal freshness period. Supermarkets and large bakery chains use electronic tracking systems that monitor stock levels and automatically reorder cakes as needed. Cakes with shorter shelf lives are often placed in refrigerated bakery sections, while long-lasting snack cakes are displayed in standard grocery aisles. In many cases, cakes are rotated based on expiration dates to minimize waste, with older stock sold first through strategic shelving placement. For specialty cakes that require customization, such as birthday cakes or event cakes, factories often provide pre-baked cake bases that can be decorated in-store. Retail bakeries receive plain sponge layers, ready-made buttercream, and pre-mixed fillings that allow decorators to assemble and personalize cakes according to customer requests. This hybrid approach combines the efficiency of factory baking with the creative flexibility of in-store decoration. Some supermarket bakeries even utilize edible printing technology to create personalized cake designs on demand, using high-resolution printers that apply edible ink onto sheets of fondant or rice paper. The demand for factory-produced cakes continues to grow as consumers seek convenient, high-quality desserts for various occasions. Large-scale cake manufacturers constantly innovate to meet changing market preferences, introducing new flavors, textures, and dietary options. Seasonal cakes, such as holiday-themed cakes or limited edition flavors, are planned months in advance, with factories adjusting their production schedules to accommodate demand spikes. These cakes often feature special packaging, festive decorations, or unique flavor combinations that align with holiday traditions and cultural celebrations. One of the biggest trends in modern cake manufacturing is the development of healthier alternatives. Consumers are increasingly looking for reduced sugar, gluten-free, and plant-based cake options that cater to dietary restrictions and health-conscious lifestyles. Factories have adapted by reformulating traditional recipes, replacing refined sugars with natural sweeteners like stevia or monk fruit, and using alternative flours such as almond flour or coconut flour to create gluten-free variations. These formulations require precise adjustments to maintain the desired texture and taste, as the absence of gluten or sugar can affect the structural integrity of cakes. Another emerging trend is the use of functional ingredients to enhance the nutritional profile of cakes. Factories are experimenting with protein-fortified cakes, fiber-rich formulations, and probiotic-infused desserts that offer health benefits beyond traditional indulgence. Cakes with added omega-3 fatty acids, collagen, or antioxidant-rich ingredients appeal to consumers who want to enjoy sweet treats without compromising on wellness goals. Manufacturers use encapsulation technology to protect sensitive nutrients during baking, ensuring that functional ingredients remain effective even after exposure to heat. Sustainability is a growing priority in cake manufacturing, with companies striving to reduce their environmental footprint at every stage of production. Many factories have implemented waste reduction programs that repurpose cake trimmings into new products, such as cake pops, cookie bases, or cereal bar inclusions. Some manufacturers donate surplus cakes to food banks or partner with organizations that distribute baked goods to communities in need. Wastewater treatment systems, energy-efficient baking ovens, and recyclable packaging materials further contribute to sustainability efforts. The shift toward eco-friendly packaging is particularly significant as traditional plastic cake containers contribute to global plastic waste issues. Factories are exploring biodegradable alternatives, such as plant-based plastics, compostable trays, and paper-based packaging with food-safe coatings. Some manufacturers have developed innovative packaging solutions that extend shelf life without relying on excessive plastic, using breathable film technology that regulates moisture levels to prevent staleness. Smart packaging, which includes QR codes that provide traceability information or freshness indicators that change color based on product age, is also gaining traction in the industry. The future of cake manufacturing is expected to be shaped by advancements in automation, artificial intelligence, and customization technology. AI-powered production lines are already capable of self-adjusting parameters based on real-time data, optimizing mixing, baking, and cooling processes for maximum efficiency. Machine learning algorithms analyze consumer purchasing patterns to predict demand fluctuations, allowing factories to adjust production schedules accordingly. 3D food printing is another exciting development that could revolutionize cake decoration and customization. Some companies are experimenting with 3D printed cake designs, where intricate sugar sculptures, chocolate accents, or even full cake layers are printed layer by layer. This technology opens up new possibilities for personalized cakes, allowing consumers to design unique cake structures that were previously impossible to achieve with traditional decorating techniques. Another potential breakthrough is the use of blockchain technology to improve transparency in the supply chain. By implementing blockchain tracking systems, cake manufacturers can provide consumers with detailed information about ingredient sourcing, production dates, and quality control measures. This level of traceability builds trust with consumers and ensures compliance with food safety regulations, especially in an era where ethical sourcing and ingredient transparency are increasingly important. As the global cake market continues to expand, manufacturers must adapt to diverse consumer preferences across different regions. In some countries, lighter sponge cakes with whipped cream fillings are preferred, while in others, dense and rich chocolate cakes dominate the market. Factories tailor their production lines to accommodate regional tastes, incorporating local ingredients and traditional flavors into their offerings. The rise of e-commerce and direct-to-consumer cake delivery services has further transformed the industry, with many factories now offering online ordering and home delivery options. The large-scale production of apple pies in a factory begins long before the first piece of dough is rolled or the first apple is peeled. The process starts with careful ingredient selection and sourcing, ensuring that only high-quality raw materials are used to maintain consistency in texture, flavor, and appearance. Apples are the most essential component, and factories work with orchards and suppliers to secure varieties that hold their shape during baking. Granny Smith, Honeycrisp, and Golden Delicious are among the most commonly used apple varieties due to their balance of tartness and sweetness, as well as their ability to remain firm when exposed to heat. These apples are harvested at peak ripeness, stored in temperature-controlled environments, and transported in bulk to the manufacturing facility. Before arriving at the factory, apples go through an initial sorting and washing process at agricultural processing plants. They are visually inspected, and any damaged or overly bruised apples are removed. Automated sorting systems use laser scanning and weight sensors to classify apples by size, ensuring uniformity in the final product. Once they reach the pie manufacturing facility, apples are subjected to another round of cleaning, where they pass through water jets, brushes, and food-safe sanitizing solutions to remove any remaining dirt, wax, or pesticide residues. Flour is another key ingredient, forming the base of the pie crust. The type of flour used depends on the desired texture of the crust. Factories often blend different flours to achieve the perfect balance of tenderness and flakiness. Large silos store refined wheat flour, which is sifted and aerated before use. Fat sources, such as butter, vegetable shortening, or margarine, are also prepared in bulk, often stored in temperature-controlled tanks or solid blocks that will later be incorporated into the dough. Sugar, cinnamon, nutmeg, and other spices are pre-measured in precise quantities to ensure flavor consistency across every batch. Before production begins, factory equipment undergoes a rigorous sanitation process. Conveyor belts, mixers, dough sheeters, peeling machines, and baking ovens are all thoroughly cleaned and sterilized to prevent cross-contamination. Strict hygiene protocols are in place, and workers handling ingredients wear protective gloves, hairnets, and sanitized uniforms. Automated ingredient dispensers are calibrated to ensure the correct proportions are used, minimizing human error and improving efficiency. The first major step in the pie making process is preparing the apples. Massive apple peeling machines process hundreds of apples per minute, using rotating blades to remove the skin efficiently. Some machines employ steam peeling, which uses high-pressure steam to loosen the skin before it is brushed off, reducing waste and preserving more of the fruit's flesh. After peeling, apples are quickly cored and sliced into uniform pieces. Factories use industrial slicers that cut apples into precise shapes, thin slices for traditional pies, or chunkier pieces for rustic-style pies. Once sliced, apples move along conveyor belts to be treated with an antioxidant solution, preventing browning caused by oxidation. This solution, typically a blend of ascorbic acid, vitamin C, and citric acid, ensures that apples maintain their natural color and freshness throughout the production process. The prepared apple slices are then transported to large mixing vats, where they are combined with sugar, spices, and thickening agents such as cornstarch or modified food starch. This ensures that the filling will have the right consistency, preventing it from becoming too runny or too dry during baking. The mixing process is carefully timed to distribute spices evenly without breaking down the apple slices. While the filling is being prepared, the pie crust is mixed and rolled out. In large-scale production, dough preparation is a highly automated process that ensures uniformity across thousands of pies. Ingredients such as flour, fat, water, and salt are combined in massive industrial mixers equipped with precision temperature controls. The temperature of the fat is crucial. If it is too warm, the dough will become overly soft and lose its flaky texture. If it is too cold, it will not incorporate properly. Factories use chilled water and climate-controlled rooms to maintain the ideal dough consistency. Once mixed, the dough is fed into an automated sheeting machine that rolls it to the exact thickness required for pie crusts. The dough is then cut into circular shapes using rotary cutters, ensuring every crust is the perfect size. Some factories employ laminating techniques to create extra layers in the dough, mimicking the effect of handmade flaky pie crusts. Excess dough from the cutting process is collected, reworked, and reintegrated into the next batch to minimize waste. The next step is assembling the pies. Conveyor belts transport the bottom crusts to the filling stations, where the prepared apple mixture is deposited into each pie shell. Factories use volumetric filling machines to ensure that each pie receives the exact amount of filling, preventing overflow or underfilling. The filling must be evenly distributed to prevent uneven baking, and any excess liquid is drained to keep the crust from becoming soggy. Once the filling is in place, the top crust or lattice is added. Factories use automated dough placers to position pre-cut dough circles onto the pies, and crimping machines press the edges together, sealing the filling inside. For lattice-top pies, robotic systems weave strips of dough in an intricate pattern, replicating the handcrafted appearance of traditional home-baked pies. Some factories also produce streusel-topped apple pies, where a crumbly mixture of butter, sugar, and flour is sprinkled over the filling before baking. Before the pies enter the ovens, finishing touches are applied. Some pies receive an egg wash or milk wash to create a glossy, golden brown crust, while others are dusted with cinnamon sugar for added flavor and visual appeal. Venting machines create small slits in the top crust, allowing steam to escape during baking and preventing the filling from bursting through the crust. The baking process is one of the most carefully controlled steps in pie manufacturing. Industrial ovens operate at precisely calibrated temperatures to ensure even baking without drying out the filling or burning the crust. Tunnel ovens, which use conveyor belts to move pies through different heat zones, are the most common in large-scale production. The first zone rapidly heats the pies to set the crust and activate the thickening agents in the filling. The middle zone maintains consistent baking temperatures, allowing the apples to soften while the crust becomes golden and flaky. The final cooling zone gradually reduces the temperature to prevent shrinkage or cracking. Once baked, the pies must be cooled before packaging. Factories use cooling tunnels equipped with controlled airflow systems to bring the pies to room temperature quickly and efficiently. This process is crucial. If pies are packaged while still warm, condensation can form inside the packaging, leading to sogginess or mold growth. Spiral cooling conveyors maximize space efficiency, allowing pies to cool gradually without taking up excessive floor space. Before packaging, each pie undergoes a final round of quality control inspections. Vision inspection systems equipped with high-resolution cameras scan each pie for imperfections such as uneven crusts, filling leakage, or discoloration. Weight sensors confirm that each pie meets precise weight specifications, ensuring consistency in every unit. Random samples are pulled for taste testing and texture analysis, verifying that the crust maintains its flakiness and that the apple filling has the right balance of sweetness and spice. After passing quality checks, pies move on to the packaging stage. Factories use automated wrapping machines that encase each pie in protective film or place them in cardboard boxes with clear plastic windows for visibility. Some pies are packaged individually for single-serve portions, while larger family-sized pies are sealed in airtight containers to preserve freshness. Packaging plays a critical role in maintaining the freshness and structural integrity of apple pies as they move through the supply chain. Once the pies have cooled completely, they are transferred to automated packaging lines where they are placed into protective containers. Factories use a variety of packaging methods depending on the type of pie being produced. Whole pies, designed for retail sale, are often placed in sturdy cardboard boxes with clear plastic windows, allowing consumers to see the product while keeping it protected. The boxes are sealed with tamper-evident closures to ensure food safety and compliance with industry regulations. For frozen apple pies, specialized packaging materials are used to prevent freezer burn and moisture loss. These pies are typically wrapped in airtight plastic film before being placed in cartons designed to withstand low temperatures. Vacuum sealing or modified atmosphere packaging techniques may also be used to remove excess oxygen and extend the shelf life of frozen pies. Factories that produce individual-sized apple pies or snack-sized turnovers use flow wrapping machines to encase each product in a flexible plastic film, preserving freshness while allowing for easy transport and handling. Once packaged, each pie is labeled with key product information, including expiration dates, ingredient lists, nutritional facts, and barcodes for inventory tracking. High-speed labeling machines apply these labels with precision, ensuring that they are aligned correctly and free from wrinkles or misprints. In some cases, additional stickers or promotional labels may be applied to highlight seasonal flavors, limited edition varieties, or special offers. Before shipping, A final round of quality control inspections takes place. Automated vision systems scan each packaged pie for defects such as misaligned labels, improper sealing, or signs of damage. Weight sensors confirm that each pie falls within the specified weight range, and metal detectors or X-ray machines are used to identify any potential foreign objects that may have inadvertently entered the production line. Randomized sampling is conducted, with select pies being opened and tested for taste, texture, and consistency to ensure they meet quality standards. Once cleared for distribution, the pies are packed into larger cartons or cases and stacked onto pallets for shipping. Logistics teams coordinate transportation, ensuring that pies reach their destinations in optimal condition. Refrigerated trucks are used for frozen pies, while shelf-stable varieties are transported under standard conditions. Large-scale manufacturers often supply pies to supermarkets, convenience stores, and food service providers, while some factories also produce private label pies for retailers under store brand names. At retail locations, apple pies are stocked in bakery sections, freezer aisles, or snack food displays, depending on their packaging and storage requirements. Supermarkets and bakeries follow strict inventory rotation practices, ensuring that older products are sold first to minimize waste. Some retailers may also offer in-store customization, allowing customers to purchase plain apple pies and add whipped cream, caramel drizzle, or other toppings before serving. In addition to retail distribution, many apple pie manufacturers supply food service businesses, including restaurants, cafeterias, and catering companies. These establishments often receive bulk shipments of pre-baked or frozen pies that can be reheated and served as needed. Some manufacturers also produce partially baked or par-baked pies, which allow food service providers to finish baking the pies in their own ovens for a freshly baked aroma and texture. As consumer preferences evolve, apple pie manufacturers continue to innovate with new flavors, formats, and dietary options. Gluten-free apple pies, for example, use alternative flours such as rice flour or almond flour to accommodate individuals with gluten sensitivities. Vegan apple pies eliminate butter and eggs, using plant-based substitutes such as coconut oil or flaxseed-based thickeners. Sugar-free and low-calorie apple pies cater to health-conscious consumers, replacing refined sugar with natural sweeteners such as stevia or monk fruit extract. Another growing trend in the apple pie industry is the development of artisanal-style products that mimic the appearance and taste of homemade pies while benefiting from large-scale production efficiency. Factories use specialized techniques to create rustic-style crusts, hand-crimped edges, and uneven lattice patterns that give the impression of being handmade. Some manufacturers also experiment with unique fillings, incorporating ingredients such as caramelized apples, bourbon-infused sauces, or spiced pecans to create gourmet variations. The production process has also seen significant advancements in automation and smart manufacturing technology. Modern pie factories utilize AI-driven production systems that monitor real-time data, adjusting mixing times, baking temperatures, and ingredient ratios automatically to ensure consistent results. Predictive maintenance technology helps prevent equipment breakdowns by analyzing performance patterns and scheduling maintenance before issues arise, reducing downtime and increasing efficiency. Sustainability initiatives are becoming increasingly important in the apple pie manufacturing industry. Many factories are adopting eco-friendly practices, such as sourcing apples from local farms to reduce transportation emissions and investing in renewable energy to power production facilities. Waste reduction programs repurpose pie trimmings and excess dough into secondary products, such as pie crust crumbs used for cheesecakes or repackaged as dessert toppings. Some manufacturers donate surplus pies to food banks, helping to combat food waste while supporting community initiatives. Packaging sustainability is another major focus, with companies seeking alternatives to traditional plastic containers. Biodegradable pie trays made from compostable materials, recycled paperboard cartons, and plant-based plastic wraps are being developed to reduce environmental impact. Some manufacturers are exploring edible packaging concepts where a protective sugar-based glaze can replace plastic wrapping while still keeping the pie fresh. The future of apple pie manufacturing is likely to see continued advancements in customization and convenience. Direct-to-consumer models are emerging, where customers can order personalized apple pies online and have them delivered fresh to their doorsteps. Smart kitchen appliances equipped with pie warming technology may become more common, allowing consumers to heat pre-packaged pies to optimal serving temperature with precision settings. 3D food printing technology is also making its way into the baking industry, with the potential to create intricate pie crust designs, decorative elements, and even printed fruit fillings layered in artistic patterns. Artificial intelligence may play a larger role in recipe development, analyzing consumer preferences and market trends to create innovative new apple pie variations. As demand for nostalgic, comforting desserts remains strong, apple pies continue to be a staple in bakeries, supermarkets, and food service establishments worldwide. The balance between tradition and technological advancement allows manufacturers to produce high-quality apple pies on a large scale while preserving the flavors and textures that consumers love. From ingredient sourcing to packaging innovation, every step of the process is designed to deliver a consistently delicious and visually appealing product. After the pies have been packaged and prepared for distribution, the journey from the production line to the consumer's hands becomes a finely tuned logistical operation. Factory staff and automated systems coordinate to load the packaged apple pies onto pallets, where each case is carefully arranged to prevent shifting during transit. This organization ensures that every pie arrives intact, with its decorative finish and flaky crust preserved. Refrigerated transport is utilized for pies that require controlled temperatures, such as those with delicate cream-based toppings or freshly prepared fruit mixtures, while room temperature varieties are shipped in climate-controlled vehicles to avoid any undesirable temperature fluctuations. Throughout this process, detailed tracking systems monitor the location, temperature, and status of shipments, ensuring that any potential issues can be quickly identified and addressed. Within the distribution centers, a well-structured system of inventory management is employed to maintain the integrity of the pies. Automated scanning and tracking devices help manage stock levels, and storage facilities are organized in a manner that optimizes space, while ensuring that pies are not exposed to excessive light or temperature changes. When orders are processed, computer-controlled systems select the appropriate batches, ensuring that the older stock is distributed first to prevent any waste. In high-demand periods, such as during holidays or seasonal promotions, the system automatically adjusts to accommodate increased volumes, demonstrating the scalability and efficiency of modern industrial food production. Retailers receive the shipments with the assurance that every pie meets strict quality criteria and that the production process adheres to both safety regulations and customer expectations. As consumer trends shift towards healthier and more diverse food options, apple pie manufacturers are continuously refining their recipes and production methods to cater to these evolving demands. One notable trend is the incorporation of organic apples and natural sweeteners. Factories are increasingly sourcing apples from certified organic orchards and experimenting with honey, maple syrup, or agave nectar as alternatives to refined sugars. These innovations are not only designed to meet the nutritional preferences of health-conscious consumers, but also to offer a richer and more nuanced flavor profile. The challenge of maintaining the perfect consistency in the filling while using these alternative ingredients has led to the development of specialized processing techniques. For example, adjustments in the proportions of thickening agents and the precise timing of the mixing process are made to account for the different moisture and sugar levels in organic produce and natural sweeteners. In response to growing concerns over allergen exposure, many apple pie factories have established dedicated production lines for allergen-free products. These production lines are segregated from the main processing areas, chooses only russet Burbank potatoes for their fries. These aren't your average spuds. They're chosen for their unique qualities, making them perfect for frying. These potatoes aren't picked just because they taste good. They're also chosen because they can keep the proper quality and texture even when made in big batches for fast food. Take the United States, for instance, where russet Burbank potatoes are a top pick, and most McDonald's contractors are from the US. Here, you can see how the potatoes are dug up from the ground with the help of heavy-duty, all-in-one machines. Inside these machines, advanced tools clean the potatoes, removing all the dirt. This process continues until all the potatoes are gathered. All these potatoes are then collected and stored in a room. This way, they can be quickly taken out when needed, ensuring that the processing never stops. You'd be amazed by the sheer quantity of potatoes here. Believe it or not a single potato goes bad. They're all used up within 15 days. A big reason for this is that McDonald's makes approximately 9 million pounds of French fries every day. As soon as these potatoes are taken to the factory as needed, that's when the real magic begins. Let's take you inside the factory, where you'll see French fries being made. First up, we've reached the potato washing station. Here, the potatoes are tossed into cleaning containers filled with water. Thanks to vibrating belts, the fast-flowing water easily washes away the dirt from the potatoes. After a thorough wash, a portion control elevator lifts the potatoes out of the water and transfers them to another belt. This belt gradually collects the potatoes in a container-like hose, sending small batches to the peeling machines for further washing. The peeling process is incredibly delicate, ensuring only the skin is removed without wasting any part of the potato. Once the potatoes are peeled and clean, they're moved through belts to the third washing chamber. Here, the final wash takes place with water containing chlorine and safe chemicals. Freshly washed and ready, these potatoes are then taken by the belts for special treatments. What you're seeing, all these units standing tall, are actually fine cutting chambers. They expertly cut the peeled potatoes into uniform sizes. This is why McDonald's fries always look the same in shape and length. Their machines work in a precise and effective way. The machines propel the potatoes at speeds of 60 to 70 mph through high-pressure water knives. These water knives finely slice the potatoes into thin strips, which are then sorted by their size and shape. After being cut, the fries are washed again and then placed on an automatic elevator, taking them toward the boiler for the next step in their journey to becoming perfect fries. Sometimes the cut fries get special treatment with a mix of sugar and sodium acid pyrophosphate for two main reasons. The sugar helps the fries achieve that perfect golden brown color when fried, while the sodium acid pyrophosphate keeps the fries from turning grey or brown, whether they're cooked or frozen. The real reason they're boiled for a bit is to make the inside of the fries soft, so when they're fried later, they turn out crispy on the outside but remain soft inside. The fries head straight to the boiler. Here, any broken or misshapen fries stick to the belts, while the perfectly shaped fries fall through to the boiling area. They're fried to 50% to lock in the quality, flavor, and freshness from the inside out. This step also removes some water and starch from the fries, creating a light crust on them. The oil they're fried in is a mix of canola, corn, soybean, and hydrogenated soybean oils. This blend is healthy because it doesn't contain trans fats or cholesterol. After the fries are half fried, they're taken out with an elevator and set aside to air dry. This usually takes about 5 to 10 minutes. During this time, any extra oil dries up, making the crispy, half-cooked fries ready for packing. The fries that are only half-cooked get frozen super fast in a special freezer tunnel. This keeps their taste and texture just right. Freezing them quickly is important to make sure they all look the same and can be stored without going bad. Potatoes can spoil quickly once they're peeled or cooked. After that, the fries are put in cool trucks or storage areas, all set to be sent off to restaurants. Cutting onions seems like the toughest part of cooking, right? It's the reason half of us are scared to even start cooking. But what if we told you that you could skip that mountainous task entirely? These machines are so efficient that no matter how you place the onion, they'll figure it out, set it right, and then, with the help of a belt that looks like a bunch of molds, make peeling and cutting super easy. First, gadgets that remove the tough outer layer grab onto the onion and peel it away in no time. Look at how cleanly and perfectly peeled these onions are now, all thanks to these fantastic machines. After a manual quality check to ensure no bad onions slip through, they're sent to be cut. This manual check is crucial. If there's a bad one, it can be caught and removed by hand. With incredibly precise cutting, all these onions are then packed and frozen, ready to help you out in the kitchen. If you want to get the job done without even touching the fish, don't worry, these machines will do everything for you. You won't have to touch them at all. These preset units seal a specific amount of fish into packets perfectly. It's rare for these machines to make mistakes. Well, to say they never do would be stretching it. They do make errors, but only at a rate of 0.001%, because they're tested over 100 times before being used in factories. First off, thanks to their excellent eyesight, these machines quickly sort out the bad apples to one side while the good apples gently move along the belt. These good apples are on their way to be turned into apple puree, which is used in a variety of delicious dishes. These machines process a ton of apples into smooth, sweet puree in no time. It's amazing to see apples zip through this process and come out as something that makes our food taste so good. The apple skins are removed and sent to another area, often ending up mixed into fodder at dairy farms. Here we have one of the biggest and most famous automated lines for making pancakes. You'll see everything from the batter being poured to the pancakes being cooked and layered, all done by machines without a hitch. These molds take a ride through an oven where the pancakes are cooked until they're just right, golden and delicious. After cooking, the pancakes are carefully picked up and arranged into neat stacks, ready to be packed and shipped out. The manufacturing of Pringles is an intricate process that combines food science, precise engineering, and large-scale automation to produce the uniform, crisp, and stackable potato chips recognized worldwide. Unlike traditional potato chips, which are sliced from whole potatoes and fried, Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, where hot air circulates around them, slowly extracting moisture until they are fully dehydrated. What remains after this process is not whole potato slices, but thin, brittle flakes of potato. These dehydrated potato flakes serve as the primary base for Pringles and are stored in large silos within the factory. However, potato flakes alone are not enough to form the distinctive shape and texture of Pringles. Additional ingredients must be added to create the dough that will eventually be shaped into chips. When it is time to begin the production of a batch, the potato flakes are carefully measured and transferred to industrial mixing machines. Inside these massive mixers, the flakes are combined with other ingredients such as cornstarch, wheat starch, emulsifiers, and small amounts of salt and sugar. These additional ingredients help give Pringles their characteristic crunch and structure, while also ensuring that the dough is flexible enough to be shaped without crumbling. Water is then gradually added to the dry mixture, and the entire batch is kneaded until it forms a smooth, pliable dough. This step is one of the most crucial in the entire process, as the consistency of the dough determines how well the chips will hold their shape and how they will fry later in the process. Too much water and the dough will be too soft, making it difficult to handle. Too little and it will become too dry, leading to chips that may crack or break during production. The mixing process is highly automated, with computer-controlled machines ensuring that every batch has the same precise ratio of ingredients. Factories use real-time monitoring systems to adjust the moisture content and consistency of the dough as needed, ensuring uniformity across millions of chips. Any slight variation in dough quality could lead to a final product that does not meet the brand's strict standards, so maintaining precise control over this step is critical. Once the dough reaches the perfect consistency, it is ready to be shaped. However, before this can happen, the dough must be processed into thin sheets. This is accomplished using large industrial rollers, which gradually flatten the dough to an exact thickness. The thickness of the dough sheet is critical as it determines the final texture and crunch of the Pringles. If the dough is too thick, the chips will be too hard. If it is too thin, they may become fragile and brittle. The flattened dough sheet is then conveyed to a cutting station, where specially designed rotary cutters stamp out individual chip shapes. Unlike traditional potato chips, which take on random forms based on how they are sliced, Pringles are designed to be identical in size and shape. Each cutter is engineered to create the precise oval form that allows the chips to stack perfectly inside their cans. During this process, any excess dough that remains after the chips are stamped out is collected and fed back into the mixing stage. This recycling process minimizes waste and ensures that as much of the raw material as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because overdrying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. The bulk packaging process is automated, with robotic arms carefully arranging the cans into pre-formed boxes or wrapping them in durable plastic film. The goal is to maximize space efficiency while ensuring that the cans are securely held in place to prevent movement during shipping. Once the bulk packaging is complete, the cartons are sealed and labeled with batch numbers, expiration dates, and tracking information. These labels allow for easy inventory management and ensure that products can be traced back to their specific production batch if necessary. The cartons are then stacked onto pallets, which are loaded onto trucks for distribution to retailers, supermarkets, and convenience stores around the world. Before being shipped out, the finished products undergo a final inspection to verify that the correct quantities and flavors have been packed for each order. Logistics teams coordinate with distribution centers to determine the most efficient shipping routes, ensuring that Pringles reach their destinations as quickly and cost-effectively as possible. Since Pringles are a globally recognized brand, this distribution network spans multiple countries, requiring careful coordination between factories, warehouses, and retailers. Throughout this entire process, Pringles manufacturers adhere to strict hygiene and safety regulations to ensure product quality and consumer safety. Factory workers follow rigorous sanitation protocols, wearing protective gear such as gloves, hairnets, and face masks to prevent contamination. The production facilities are regularly inspected by quality assurance teams and food safety organizations to ensure compliance with industry standards. In addition to maintaining high production standards, Pringles manufacturers are constantly exploring ways to improve sustainability and reduce waste. The company has implemented initiatives to minimize environmental impact, such as optimizing energy usage in production plants, recycling excess packaging materials, and reducing food waste by repurposing rejected chips and excess dough. In some regions, Pringles packaging has been redesigned to use more eco-friendly materials, with ongoing efforts to further enhance the sustainability of the product. While the cans of Pringles are now ready to be shipped to stores, the journey does not end there. Once they arrive at retail locations, they must be carefully stocked to ensure they remain in pristine condition for customers. Store employees follow specific stocking guidelines to prevent the cans from being crushed or stacked improperly. The cylindrical shape of the canisters allows them to be displayed neatly on shelves, creating an organized and visually appealing presentation. For consumers, the convenience of Pringles packaging is one of its most attractive features. The resealable lid allows snackers to enjoy the chips at their own pace while keeping them fresh between servings. Unlike traditional chip bags that often trap excess air and lead to crushed chips, the rigid canister provides a level of protection that helps maintain the product's quality. The success of Pringles is not only due to the meticulous manufacturing process, but also to the brand's ability to continually innovate. Over the years, new flavors and limited edition varieties have been introduced to cater to different tastes and cultural preferences. Research and development teams work to create unique seasoning blends and textures that keep consumers engaged with the brand. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. Artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system, where excess moisture is removed before they enter the frying stage. Proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle, their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, 3 factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures, including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, the production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world. Bananas begin their journey in the tropical plantations, where they are carefully cultivated to meet the demands of the global market. The process starts with the selection of optimal banana varieties, with Cavendish bananas being the most widely produced due to their durability and resistance to transportation stress. The banana plants, which are technically large herbs rather than trees, are cultivated in nutrient-rich soil under warm and humid conditions. Farmers carefully monitor the growth of banana plants, ensuring that they receive the right amount of water, nutrients, and protection from pests and diseases. Once the bananas reach the correct stage of maturity, typically around 9 months after planting, the harvesting process begins. Workers use sharp machetes or mechanical cutting tools to carefully cut the large banana bunches, which can weigh up to 50 kilograms. These bunches are placed onto conveyor systems or carried manually to avoid damage. Harvested bananas are quickly transported to centralized collection points, where they undergo a thorough sorting and initial quality inspection. Workers remove any damaged or overly ripe bananas, ensuring only the best quality fruit continues through the production process. The bananas are then washed in large water tanks, often infused with disinfectants to remove dirt, sap, and potential contaminants. This washing step also helps prevent the spread of diseases and fungi that could compromise the fruit's shelf life. Once cleaned, the bananas move onto grading stations, where they are categorized based on size, shape, and external appearance. Factory production standards dictate that only bananas meeting strict criteria proceed to the next stage. At this point, the bananas are separated from the large bunches into smaller clusters, typically consisting of 4 to 7 bananas. These clusters are cut with precision to maintain a uniform presentation. Automated machines or skilled workers carefully trim excess stems to the appropriate length, preventing damage during transportation and further processing. After trimming, the bananas are once again rinsed and placed onto conveyor belts, leading to the next stage of processing. Temperature control is crucial throughout the handling of bananas. To slow down ripening and ensure the fruit remains in peak condition, the bananas are placed in large cooling rooms set to around 13 to 15 degrees Celsius. These controlled conditions help preserve the bananas during transportation to industrial processing facilities, where they undergo further treatment, packaging, and preparation for global distribution. Bananas are highly perishable, so every step of the journey is carefully managed to maximize freshness. Once the bananas arrive at a dedicated processing facility, they undergo another round of inspections. Workers and automated sorting systems check for any defects that may have developed during transportation. The bananas are then placed into climate-controlled storage areas, ensuring that they do not ripen too quickly before packaging. Some bananas are destined for direct sale, while others will be processed into banana-based products such as dried bananas, banana puree, or banana chips. Each of these processing paths requires different equipment and techniques to achieve the desired final product. For fresh banana packaging, the fruit is arranged in trays or cartons designed to protect them from bruising. Packing lines employ automated machinery that gently places the bananas into their designated packaging, ensuring consistent weight and size in each package. Special padded trays or foam inserts are often used to cushion the bananas and minimize damage. The packaged bananas are then labeled, with stickers applied either manually or by automated applicators. These labels often include barcodes, brand names, and country of origin details. To extend shelf life and prevent premature ripening, some banana shipments are treated with ethylene inhibitors. These substances help slow down the natural production of ethylene gas, which is responsible for the ripening process. In cases where bananas need to ripen on demand, specialized ripening chambers are used at distribution centers. These chambers allow controlled exposure to ethylene gas, ensuring the bananas reach optimal ripeness just before being sent to retail stores. For bananas that will be further processed into products like banana chips, the production process involves additional steps such as peeling, slicing, and dehydration. High-speed peeling machines are used to remove the thick banana skins efficiently. The peeled bananas are then transported via conveyor belts to slicing machines, which cut them into uniform pieces based on the desired end product. These slices are then either fried in hot oil to create banana chips or placed in large dehydration ovens to produce dried banana snacks. The production of banana puree involves an entirely different set of machinery and techniques. After peeling, the bananas are mashed using industrial pulping machines, which break down the fruit into a smooth consistency. The puree is then passed through filtration systems to remove any fibrous material or unwanted particles. Depending on the intended use, the banana puree may undergo pasteurization, a heating process designed to kill bacteria and extend shelf life. The final product is then packaged in large containers or smaller, retail-friendly pouches. Throughout every stage of banana processing, quality control measures are strictly enforced. Automated sensors and human inspectors check for consistency in size, shape, color, and taste. Any defective or subpar bananas are removed from the production line and either repurposed for animal feed, compost, or other secondary uses. Ensuring food safety is paramount, and factories adhere to strict sanitation protocols to prevent contamination. Conveyor belts, slicing machines, and packaging stations are regularly cleaned and maintained to uphold hygiene standards. Once the bananas or banana-based products are ready for distribution, they are carefully loaded onto climate-controlled trucks or shipping containers. These vehicles maintain a stable temperature to prevent premature ripening or spoilage. The journey from processing facilities to retailers involves careful logistical planning, ensuring that consumers receive fresh, high-quality bananas at the right stage of ripeness. In cases where bananas are shipped internationally, advanced tracking systems monitor temperature conditions throughout transit, guaranteeing optimal quality upon arrival. Bananas destined for large-scale retail distribution often undergo one final quality check upon arrival at regional distribution centers. Here, ripening specialists assess the fruit's condition and determine whether ethylene gas exposure is necessary to accelerate the ripening process before shipment to supermarkets. Once the bananas reach grocery stores, they are displayed in carefully arranged sections to attract customers while minimizing handling damage. As the bananas move through the processing facility, their journey continues with additional quality control measures. Every banana that passes through the system is subject to strict oversight to ensure it meets the standards set by global markets. Some bananas are set aside for immediate export, while others are prepared for processing into various banana-based products. Each batch is tracked using barcodes or digital systems to maintain traceability, allowing factories to monitor their origins and ensure compliance with regulatory requirements. Bananas that are destined for further processing must first undergo additional cleaning. Large industrial washers use gentle streams of water combined with food-safe sanitizers to remove any remaining residues from the outer peel. For bananas that will be processed into products requiring peeled fruit, high-efficiency peeling machines are employed. These machines operate with incredible precision, using rotating blades and suction systems to remove the thick banana skin without damaging the soft fruit inside. The peeled bananas are then conveyed along sanitized belts toward the next stage of production. For bananas intended for drying, the peeled fruit is sliced into uniform pieces using high-speed industrial slicers. These slices can be adjusted to produce different thicknesses depending on the desired final texture of the dried product. Once sliced, the banana pieces are spread out evenly on large drying trays or conveyor belts, ready to enter specialized dehydration chambers. The drying process typically involves controlled exposure to warm air, which removes moisture while preserving the fruit's natural sweetness. The temperature and humidity levels are carefully monitored to ensure the bananas do not become too brittle or lose their natural flavor. Depending on the facility, some manufacturers may opt for freeze-drying techniques, which use a vacuum process to extract moisture while retaining the fruit's structure and nutrients. Banana chips, a popular snack food, require a different production approach. Instead of dehydration, the sliced bananas are deep-fried in vegetable oil at high temperatures. Large industrial fryers are used to ensure an even cooking process. The frying time is precisely calibrated to achieve a crisp texture without overcooking or burning the banana slices. Some manufacturers enhance the chips by seasoning them with salt, sugar, or other flavorings before they are packaged. Excess oil is removed using centrifugal draining machines, which spin the banana chips to ensure a light and crispy texture. Banana puree production follows another distinct processing pathway. After peeling, the bananas are mashed in large industrial pulping machines. These machines use rotating blades or rollers to break down the fruit into a smooth, consistent mixture. To prevent oxidation and maintain the puree's natural yellow color, antioxidants such as ascorbic acid are often added during this stage. The banana puree is then subjected to pasteurization, where it is heated to a controlled temperature to kill any harmful microorganisms while preserving its nutritional content. Pasteurization is critical for extending the shelf life of banana puree, making it suitable for use in baby food, smoothies, and baking applications. Once the puree has been properly treated, it is packaged in large industrial containers, aseptic pouches, or smaller retail-friendly jars, ready for distribution. Every stage of banana processing requires stringent hygiene controls. Factories implement rigorous sanitation protocols, ensuring that all equipment, conveyor belts, and processing surfaces are regularly cleaned and sterilized. Workers involved in banana handling follow strict hygiene guidelines, wearing protective gloves, hairnets, and sanitized uniforms to prevent contamination. Automated monitoring systems continuously track environmental conditions, ensuring that temperature, humidity, and air quality remain within optimal ranges. Once processed, bananas and banana-derived products are carefully packed to prevent damage and preserve freshness. For fresh bananas, packing stations use automated sorting machines that place the fruit into protective cartons, ensuring uniform weight and size distribution. Banana chips are packaged using nitrogen-flushed bags to prevent oxidation and maintain crispness. Dried bananas and banana puree are sealed in airtight containers, minimizing exposure to moisture and contaminants. Packaging materials are chosen for their durability, ensuring that products remain intact throughout transportation and storage. After packaging, the bananas are prepared for distribution. Fresh bananas are loaded into climate-controlled shipping containers that maintain a stable temperature between 13 and 15 degrees Celsius, preventing premature ripening. These containers are equipped with ventilation systems that regulate air composition, ensuring optimal freshness upon arrival at their destination. Processed banana products follow a different logistics chain, with dried bananas, chips, and puree being transported in standard freight containers under controlled storage conditions. Ripening facilities play a crucial role in the banana supply chain. Upon arrival at distribution centers, fresh bananas may be placed into specialized ripening rooms, where controlled amounts of ethylene gas are introduced. Ethylene is a natural plant hormone that triggers the ripening process, allowing bananas to develop their characteristic yellow color and sweet flavor. Ripening rooms are carefully monitored, with temperature and humidity levels adjusted to ensure uniform ripening without over-ripening or spoilage. Once the bananas reach the desired ripeness, they are shipped to supermarkets, where they are displayed for consumers. In modern banana factories, automation is increasingly integrated into the production process. Advanced robotic systems handle delicate fruit with precision, minimizing bruising and maximizing efficiency. Optical sensors analyze banana quality, sorting them based on color, size, and ripeness. Conveyor belt systems are equipped with real-time monitoring technology, allowing factory managers to track production rates and detect potential issues before they impact output. The integration of data analytics and machine learning further enhances production efficiency, optimizing banana processing workflows based on demand trends and supply chain logistics. Sustainability is also a growing focus in banana manufacturing. Many factories implement eco-friendly initiatives to reduce waste and energy consumption. Banana peels and rejected fruit are repurposed as organic compost, animal feed, or biofuel. Some facilities incorporate solar panels and energy-efficient machinery to lower their carbon footprint. Water recycling systems help minimize water usage, ensuring that banana processing remains environmentally responsible. Efforts to improve fair trade practices and support banana farmers have also gained traction, ensuring ethical and sustainable sourcing of raw materials. Banana production is a complex and highly coordinated process that involves multiple stages of handling, processing, and distribution. From the moment bananas are harvested on plantations to the point where they reach consumers as fresh fruit or processed products, every step is meticulously managed to maintain quality, safety, and efficiency. Advances in technology continue to refine banana processing methods, making it possible to deliver high-quality bananas and banana-based products to markets worldwide. As the banana industry evolves, manufacturers continue refining their processes to improve efficiency, reduce waste, and maximize product quality. The journey from banana plantations to industrial processing facilities is a highly orchestrated operation involving both traditional agricultural techniques and cutting-edge automation technologies. At every stage, from harvesting to packaging, strict protocols are followed to ensure that only the highest quality bananas make it to market. Once bananas have been harvested and sorted, those destined for industrial processing are transported in specialized containers to prevent damage. The journey from the plantation to the factory is carefully managed, with transportation schedules optimized to reduce delays and prevent premature ripening. Bananas that arrive at the factory in a raw state are first subjected to an additional round of inspections. Quality control teams examine each shipment, ensuring that the fruit meets the necessary criteria before it proceeds to the next stage. Upon arrival at the processing facility, bananas undergo a pre-treatment phase. This begins with a thorough cleaning process, where the fruit is washed in large, food-grade water baths. These washing stations are equipped with high-powered jets that remove any residual dirt, pesticides, or surface contaminants. Some factories add mild disinfectants or organic sanitizing agents to the water to eliminate bacteria and fungi that could affect the final product's shelf life. Once washed, the bananas are conveyed to sorting lines, where automated systems use sensors to categorize them based on size, ripeness, and surface quality. For fresh banana packaging, the bananas that meet industry standards are arranged into clusters and gently placed into protective cartons. Advanced robotic arms are sometimes used to handle the fruit, ensuring minimal human contact and reducing the risk of bruising. Packaging lines use precision weighing systems to guarantee uniformity in product distribution. Some packaging facilities use modified atmosphere packaging, where the oxygen levels inside the packaging are carefully controlled to slow down the ripening process. Bananas that are set aside for further processing move to dedicated peeling stations. Peeling bananas on an industrial scale requires specialized machinery that can efficiently remove the thick outer skin while preserving the soft interior. High-speed mechanical peelers use a combination of cutting blades and suction mechanisms to remove the peel in a single motion. For certain banana-based products, additional peeling techniques are employed, such as steam-assisted peeling, where a rapid blast of steam loosens the peel before mechanical separation. Once peeled, the bananas are inspected again to remove any that are overly bruised or damaged. The peeled bananas are then directed to their respective processing lines based on the final product they will be used for. Bananas designated for puree production are immediately transported to industrial mashing machines, where they are blended into a smooth consistency. These machines operate at high speeds, using rotating blades or pressure systems to break down the fruit into a fine pulp. To maintain the puree's natural color and prevent oxidation, citric acid or ascorbic acid may be added. The puree is then filtered to remove any fibrous material or unwanted solids, ensuring a smooth and consistent texture. Bananas intended for drying are sliced using automated slicing machines that produce even, uniform pieces. These banana slices are then placed onto mesh conveyor belts, which carry them through drying tunnels. The drying process varies depending on the manufacturer, but it typically involves controlled exposure to warm air at temperatures between 50 and 70 degrees Celsius. This gradual dehydration process removes moisture while preserving the natural sugars in the fruit, resulting in a sweet and chewy texture. Some manufacturers opt for freeze drying, which involves rapidly freezing the banana slices before placing them in a vacuum chamber to remove moisture. This method helps retain more of the banana's original flavor and nutritional content. Banana chips, a widely popular snack, undergo a frying process to achieve their crispy texture. The peeled bananas are first cut into thin slices before being submerged in large vats of hot vegetable oil. The frying process takes only a few minutes, during which the banana slices turn golden brown and develop their characteristic crunch. After frying, excess oil is removed using centrifugal draining machines, which spin the chips at high speeds to eliminate any remaining grease. To enhance flavor, the banana chips may be lightly salted, sweetened with honey, or coated in flavored seasonings before being packaged. Throughout every stage of production, factories implement rigorous quality control measures to ensure food safety and consistency. Optical scanners and high-speed cameras are used to detect imperfections, sorting out any defective bananas or banana products. Workers in food safety laboratories conduct regular microbial testing, checking for bacteria, yeast, and mold that could compromise product quality. Metal detectors and X-ray machines scan packaged products for any foreign contaminants before they are cleared for distribution. The final stage of banana processing involves packaging and storage. Fresh bananas are packed in ventilated cartons that provide airflow to regulate ripening. Banana chips and dried banana products are sealed in airtight packaging to maintain freshness and prevent moisture absorption. Banana puree is packaged in sterile, food-grade containers, which are often vacuum sealed or heat treated to ensure an extended shelf life. In large-scale food manufacturing, bulk containers of banana puree may be shipped to other processing facilities, where they are used in products such as baby food, smoothies, yogurt, and baked goods. Once packaged, the banana products are stored in climate-controlled warehouses before being transported to retailers and distribution centers. Logistics teams carefully plan shipping routes to minimize transit time and ensure that the products arrive in optimal condition. Fresh bananas are typically shipped in refrigerated trucks or containers, where the temperature is carefully regulated to prevent premature ripening. Ripening centers at distribution hubs monitor the banana's condition, exposing them to controlled amounts of ethylene gas when necessary to trigger the final ripening process before they reach grocery store shelves. Banana factories continuously innovate to improve efficiency and sustainability. Many facilities have adopted eco-friendly initiatives to reduce waste and energy consumption. For instance, banana peels and other byproducts from the production process are repurposed as compost, livestock feed, or biofuel. Some factories incorporate water recycling systems, filtering and reusing water from the washing process to minimize resource consumption. The use of solar energy and other renewable power sources is also becoming more common in banana processing plants, helping to reduce the industry's overall carbon footprint. The integration of smart technology and automation is revolutionizing banana production. Artificial intelligence, AI, and machine learning algorithms are used to optimize sorting, detect defects, and predict supply chain trends. Advanced robotics are being implemented to handle delicate fruit more efficiently, reducing human labor costs while increasing processing speeds. Data analytics tools allow factory managers to track production in real time, making adjustments to improve efficiency and reduce waste. The demand for banana-based products continues to grow, driven by consumer preferences for healthy, natural snacks and ingredients. Banana processing plants are expanding their product offerings to include innovative items such as banana flour, banana-based protein bars, and freeze-dried banana snacks. The industry is also focusing on sustainable sourcing, ensuring that bananas are grown using environmentally responsible farming practices that support fair wages and ethical labor conditions for workers. As the banana industry expands, factories are continuously developing new techniques to optimize efficiency, reduce waste, and maintain high product quality. The production cycle is carefully monitored, from the moment bananas are harvested in plantations to their transformation into various consumer products. Each stage is executed with precision to meet global market demands while ensuring sustainability and food safety. Once fresh bananas have been sorted, cleaned, and prepared for processing, the next step depends on their intended use. Some bananas will be packaged for fresh consumption, while others will be transformed into banana puree, dried banana products, or banana-based ingredients used in food manufacturing. For fresh bananas, factories implement protective packaging solutions to prevent bruising and ensure that the fruit remains in excellent condition throughout transportation and storage. These packaging solutions may include cushioned cartons, foam inserts, or breathable plastic wraps that regulate moisture levels and slow down ripening. Fresh bananas are often shipped in refrigerated trucks that maintain a stable temperature of around 13 to 15 degrees Celsius. This temperature range is crucial as it prevents premature ripening while keeping the fruit firm and fresh. Advanced logistics tracking systems monitor temperature fluctuations in real time, ensuring that bananas are transported under optimal conditions. If temperatures rise too high during transit, the bananas may ripen too quickly, leading to shorter shelf life and increased waste. Conversely, if temperatures drop too low, chilling injury can occur, causing the bananas to develop brown or black spots and compromising their quality. For bananas that undergo further processing, the industrial peeling phase is a critical step. While some banana-based products require manual peeling, most large-scale factories use specialized peeling machines to remove the thick banana skins efficiently. These machines operate using rotating blades or suction systems, ensuring that the fruit is peeled quickly and cleanly. In some cases, banana peels are softened using a brief steam treatment before being mechanically separated from the fruit. This method helps reduce waste and increases the yield of usable banana flesh. Once peeled, the bananas must be processed quickly to prevent oxidation, which can cause them to turn brown. For banana puree production, the peeled bananas are immediately transferred to high-speed pulping machines. These machines use rotating metal drums with fine mesh screens to break down the fruit into a smooth, uniform puree. The puree is then passed through filtration systems to remove any unwanted fibers or solid particles. To maintain color and flavor, natural antioxidants such as citric acid or ascorbic acid are added. Some manufacturers also incorporate mild pasteurization, heating the puree to a controlled temperature to eliminate bacteria and extend shelf life without compromising nutritional value. The banana puree is then packaged in aseptic containers, ensuring that it remains free from contamination. In some cases, the puree is concentrated by removing excess water, creating a thicker, more versatile product used in baby food, baked goods, and smoothies. The concentrated puree is typically stored in large industrial drums or vacuum-sealed pouches before being distributed to food manufacturers worldwide. For dried banana production, the peeled fruit is sliced into uniform pieces using precision slicing machines. These machines ensure that each banana slice maintains a consistent thickness, which is essential for even drying. The banana slices are then arranged on conveyor belts or drying racks, ready to enter industrial dehydration chambers. The drying process varies depending on the manufacturer and the intended final product. Traditional air drying methods involve exposing the banana slices to warm, circulating air at temperatures between 50 and 70 degrees Celsius. This gradual drying process removes moisture while preserving the fruit's natural sweetness and texture. Some manufacturers use freeze drying, a technique that involves freezing the banana slices and then placing them in a vacuum chamber. The vacuum removes moisture without subjecting the fruit to heat, resulting in a crisp, lightweight product that retains more of the banana's original nutrients and flavor. For banana chips, the production process is slightly different. Instead of drying, the banana slices are submerged in hot vegetable oil and fried until they develop a crunchy texture. Large industrial fryers maintain a consistent oil temperature, ensuring even cooking and a uniform golden brown color. After frying, excess oil is removed using centrifugal draining machines, which spin the chips at high speeds to extract any remaining grease. Some manufacturers apply additional flavoring, such as salt, sugar, cinnamon, or honey glaze, before packaging the banana chips in airtight bags to preserve freshness. Throughout the processing stages, factories implement strict food safety and quality control measures. Automated sorting systems use high-resolution cameras and optical sensors to inspect banana slices, puree, and chips for consistency in color, size, and texture. Any defective or substandard products are removed from the production line. Metal detectors and X-ray scanners check packaged banana products for potential contaminants, ensuring that every item meets the required safety standards before it reaches consumers. Banana factories also prioritize waste reduction and sustainability. Peels and other organic byproducts from the production process are repurposed in various ways. Some factories use banana peels as livestock feed, while others process them into compost or biofuel. Advanced waste management systems help minimize environmental impact, with some manufacturers investing in water recycling technologies to reduce water consumption during the cleaning and washing stages. As consumer demand for banana-based products grows, factories continue to innovate and expand their offerings. Beyond traditional banana puree, chips, and dried bananas, manufacturers are exploring new product categories, including banana flour, pre-packaged banana smoothie blends, and high-protein banana bars. Banana flour, made by grinding dried bananas into a fine powder, is gaining popularity as a gluten-free alternative for baking and cooking. This versatile ingredient is used in everything from bread and pancakes to energy bars and nutritional supplements. Banana processing facilities also invest heavily in automation and smart technology to improve efficiency. AI-powered sorting machines analyze banana quality in real time, adjusting processing parameters to optimize output. Robotic arms are increasingly used for packaging, reducing the need for manual handling and minimizing product damage. Real-time data analytics help factory managers monitor production performance, identify inefficiencies, and implement improvements that enhance productivity and reduce costs. The global banana industry relies on a well-coordinated supply chain to ensure that fresh and processed bananas reach consumers in peak condition. Distribution networks are carefully managed, with warehouses and ripening centers strategically located near major markets. Retailers use advanced inventory management systems to track banana shipments and predict demand, ensuring that stores remain stocked with fresh bananas while minimizing waste. In ripening centers, fresh bananas undergo controlled ethylene exposure to accelerate ripening before they are sent to supermarkets. The timing of this ripening process is critical, as it determines the banana's appearance and texture upon reaching store shelves. Ethylene gas concentrations, temperature, and humidity are carefully regulated to achieve uniform ripening without over-ripening or spoilage. Banana factories continue to evolve, integrating the latest advancements in food technology, sustainability, and logistics. As consumer preferences shift toward healthier and more sustainable food choices, the banana industry is adapting by offering organic, fair trade, and minimally processed banana products. These initiatives ensure that banana production remains both economically viable and environmentally responsible, meeting the needs of a growing global population while reducing the industry's ecological footprint. The meticulous handling of bananas throughout their journey from plantation to processing facility ensures that they maintain their freshness and quality, whether they are destined for fresh consumption or further industrial processing. The seamless transition between these stages requires advanced logistical coordination, as bananas must be transported quickly to prevent over-ripening while maintaining optimal storage conditions. Once inside the processing facility, each banana undergoes a series of treatments tailored to its final intended use. Bananas that are meant for fresh sale are carefully packaged in protective cartons, but the process doesn't end there. These fresh bananas are often stored in climate-controlled warehouses, where specialized ripening chambers help regulate their maturation. Since bananas ripen naturally through the release of ethylene gas, these chambers provide a controlled environment where ethylene exposure is adjusted based on shipment schedules. This process ensures that bananas arrive at supermarkets at the perfect stage of ripeness, ready for consumers to purchase. The ripening rooms are monitored with precision sensors that measure humidity, temperature, and gas concentration, ensuring that no batch over-ripens or becomes too soft before reaching store shelves. Meanwhile, for bananas destined for further processing, their journey involves a more intensive transformation. Once peeled using specialized machinery, these bananas are quickly moved into processing lines to prevent oxidation, which can lead to undesirable browning and flavor changes. Depending on their end use, the bananas are either mashed into puree, sliced for drying, or prepared for frying into banana chips. Banana puree production requires high-speed pulping machines that use stainless steel blades to break down the fruit into a smooth consistency. These machines operate in continuous production lines, with the puree moving through filtration systems that remove any unwanted fibers, seeds, or imperfections. The temperature of the puree is maintained at controlled levels to preserve its natural sweetness and prevent microbial growth. Some manufacturers incorporate flash pasteurization, a brief but effective heat treatment to extend the puree's shelf life without compromising flavor or nutritional value. The final product is then stored in sterilized tanks before being packaged in either small retail pouches or industrial-sized drums for bulk distribution. For dried banana products, the process is slightly different. Once peeled, bananas are fed into high-precision slicing machines that ensure each piece is uniform in size and thickness. The slices are then transferred to conveyor systems that guide them through dehydration chambers, where controlled airflow and heat gradually remove moisture from the fruit. This drying process can take several hours, depending on the desired texture and final moisture content of the product. Some manufacturers use vacuum drying or freeze drying techniques to enhance texture and retain more nutrients. These methods help produce crisp, long-lasting banana snacks that remain shelf-stable for extended periods. In banana chip production, the peeled and sliced bananas are submerged in industrial frying vats filled with hot vegetable oil. These vats operate at precise temperatures to ensure the banana slices fry evenly, developing a golden brown crispiness without burning. After frying, excess oil is removed using high-speed centrifugal drying machines which spin the chips rapidly to eliminate residual grease. Some manufacturers season the chips immediately after frying, using automated sprayers to apply salt, sugar, or various flavor coatings. The finished banana chips are then transported to packaging stations, where they are sealed in airtight bags to preserve their crunch and prevent oxidation. Throughout the entire banana processing workflow, factories implement stringent quality control measures. Automated vision systems equipped with high-resolution cameras inspect banana slices, puree, and chips for consistency in size, color, and texture. Any substandard products are diverted from the main production line and repurposed for secondary uses such as animal feed or composting. Metal detectors and X-ray scanners provide additional safety checks, ensuring that no foreign contaminants are present in the final packaged products. The packaging process itself is highly automated, with conveyor belts guiding products into pre-measured containers. Fresh bananas are placed in breathable cartons that allow for ventilation, while banana chips and dried banana slices are packaged in nitrogen-flushed bags that prevent oxidation and extend shelf life. For banana puree, aseptic packaging methods are used to maintain product freshness without the need for refrigeration. Some large-scale food manufacturers purchase banana puree in bulk containers, which are then integrated into their own production lines for making baby food, desserts, and bakery items. Once packaged, banana products must be stored and distributed efficiently. Climate-controlled warehouses maintain optimal conditions for each type of banana product, ensuring that fresh bananas do not ripen too quickly and that processed banana items remain stable. Logistics teams coordinate shipments using real-time tracking systems, optimizing delivery routes to minimize transportation times and ensure products arrive in peak condition. Fresh bananas are often transported in refrigerated containers that maintain a consistent temperature, preventing premature ripening. These containers are equipped with ventilation controls that regulate humidity and air composition, ensuring that bananas remain firm and resistant to bruising during long-distance transit. Upon arrival at distribution centers, these bananas undergo a final ripening stage, where ethylene exposure is carefully managed to achieve the perfect color and texture before they are shipped to grocery stores. Banana-based products, such as chips, dried bananas, and puree, follow a slightly different distribution model. Since these products have longer shelf lives, they are often stored in dry warehouses before being shipped to retail stores or food manufacturers. These warehouses use advanced inventory management systems to track stock levels and prevent overproduction, ensuring a steady supply chain without excessive waste. The sustainability aspect of banana processing is a growing focus for manufacturers. Many factories have adopted eco-friendly initiatives to reduce their environmental impact. Banana peels and other organic byproducts are repurposed in various ways, such as being converted into animal feed, biofuel, or compost for agricultural use. Some facilities implement water recycling systems to minimize waste in the washing and processing stages, ensuring that water usage remains efficient. Additionally, energy-efficient machinery and solar-powered production plants are becoming more common, helping factories reduce their overall carbon footprint. In recent years, consumer demand for ethically sourced and organic bananas has driven changes in banana processing. More factories are adhering to fair trade standards, ensuring that banana farmers receive fair wages and that environmentally sustainable farming practices are followed. Organic banana production eliminates synthetic pesticides and fertilizers, requiring stricter handling protocols to maintain certification standards. These organic bananas go through the same processing methods, but must be kept separate from conventionally grown bananas throughout the supply chain to maintain their organic status. Technology continues to revolutionize banana processing, with artificial intelligence and automation playing an increasing role. AI-driven quality control systems analyze bananas for defects with greater accuracy than human inspectors, reducing waste and improving overall efficiency. Automated robotic arms handle delicate bananas with precision, ensuring minimal bruising during sorting and packaging. Data analytics software optimizes supply chain logistics, predicting demand patterns and helping factories adjust production schedules to meet market needs. The efficiency of banana processing factories relies on a combination of cutting-edge automation, rigorous quality control, and sustainable practices. From the moment bananas enter the facility to their final packaging and distribution, every step is carefully designed to maximize freshness, preserve nutritional value, and minimize waste. While fresh bananas undergo controlled storage and ripening processes to ensure peak quality upon arrival at retail stores, processed banana products like puree, chips, and dried slices follow more complex manufacturing pathways requiring specialized equipment and techniques. One of the critical elements of banana processing is maintaining the delicate balance between speed and quality. Since bananas are highly perishable, factories must operate with precision to prevent spoilage and ensure that only the highest quality fruit is used. Advanced sorting lines use a combination of human inspection and artificial intelligence-driven sensors to evaluate bananas based on their color, size, firmness, and surface condition. High-resolution cameras scan each banana as it moves along conveyor belts, identifying bruises, blemishes, or irregularities that could affect product quality. Any substandard bananas are automatically diverted to secondary processing lines where they may be repurposed for animal feed, composting, or biofuel production. For fresh banana packaging, factories utilize automated systems that gently place bananas into protective cartons or plastic trays. Each package is weighed to ensure consistency, with advanced robotic arms adjusting the number of bananas per carton if necessary. The packaging materials are designed to provide adequate ventilation while minimizing physical damage during transportation. Some factories also use biodegradable or recyclable packaging solutions, aligning with global sustainability trends and reducing plastic waste in the supply chain. Bananas that undergo further processing are peeled using high-speed peeling machines, which separate the edible fruit from its thick outer skin with remarkable efficiency. The peeled bananas are then subjected to additional cleaning, where they are rinsed in purified water infused with mild food-grade sanitizers to eliminate any remaining contaminants. Once cleaned, the bananas are directed toward their designated production lines based on the final product requirements. Banana puree production requires industrial-scale pulping machines, which operate using rotating blades or pressure-based extraction methods to break down the fruit into a uniform consistency. These machines are engineered to handle large volumes of bananas per hour, ensuring continuous output without interruptions. To prevent the puree from oxidizing and developing an undesirable brown hue, factories introduce natural preservatives such as lemon juice or ascorbic acid. The puree then undergoes pasteurization, a crucial step that involves briefly heating the product to eliminate harmful microorganisms while preserving its fresh taste and nutritional content. After pasteurization, the banana puree is rapidly cooled and transferred into sterilized storage tanks or aseptic packaging containers. For dried banana production, the peeled fruit is carefully sliced into even round or strips using precision cutting machines. The sliced bananas are then arranged on large drying trays or mesh conveyor belts that transport them through industrial dehydration chambers. These chambers use controlled heat and airflow to gradually reduce the moisture content of the bananas while retaining their natural sweetness. The drying time varies based on the desired texture, with chewy dried bananas requiring slightly higher moisture retention than crispy banana chips. Some manufacturers opt for vacuum drying or freeze drying methods, which help preserve the banana's original structure, flavor, and nutrient profile more effectively than conventional drying techniques. Banana chip production follows a different path, involving deep frying to achieve a crunchy texture. Once sliced, the banana pieces are fed into large capacity frying vats filled with hot vegetable oil. The frying process lasts only a few minutes, during which the natural sugars in the bananas caramelize, enhancing their sweetness and contributing to their golden brown appearance. Once fried, the banana chips are rapidly cooled and transferred to centrifugal drying machines, which remove excess oil and ensure a light, crisp finish. Some manufacturers add flavor enhancements such as cinnamon, honey, or even spicy seasonings before sealing the chips in airtight packaging. Quality control is a non-negotiable aspect of banana processing. Each production batch is subjected to multiple layers of testing, ensuring compliance with food safety regulations and consumer expectations. Optical scanners analyze banana slices and puree for consistency in texture and color, while microbial testing ensures that products remain free from harmful bacteria, yeast, and mold. Factories also employ metal detection and X-ray inspection systems to identify any potential foreign contaminants before the products are packaged and shipped. The packaging stage is highly automated, with conveyor belts guiding banana products into their respective containers. Fresh bananas are packed in ventilated cartons that allow for sufficient airflow, ensuring gradual ripening without over-ripening. Banana puree is sealed in vacuum-packed pouches or bulk-sized aseptic containers, which protect the product from oxidation and contamination. Dried bananas and banana chips are packaged in moisture-proof bags filled with nitrogen gas to prevent oxidation and preserve crispness. Once packaged, banana products are moved to temperature-controlled storage areas before distribution. Fresh bananas are carefully stored in ripening chambers at distribution centers, where ethylene gas exposure is calibrated to trigger controlled ripening before shipment to supermarkets. This process ensures that bananas reach store shelves at the perfect stage of ripeness, allowing consumers to enjoy them at their peak. For banana-based processed products, distribution logistics involve coordination between factories, warehouses, and retailers. Bulk banana puree shipments are often sent to food manufacturers, where they are used as ingredients in smoothies, yogurt, baby food, and baked goods. Dried bananas and banana chips are transported to grocery stores, convenience shops, and online retailers, where they are sold as snacks. Advanced inventory management systems track product movement in real time, ensuring that retailers receive fresh supplies while minimizing storage time. Sustainability initiatives play an increasingly vital role in banana processing. Many factories implement zero-waste policies, where byproducts such as banana peels and unused fruit are repurposed rather than discarded. Some facilities process banana peels into animal feed, organic fertilizers, or even bioplastics. Others convert banana waste into bioethanol, an alternative fuel source that reduces dependence on fossil fuels. Water conservation measures, such as recycling systems that purify and reuse water from the washing process, further contribute to the industry's environmental responsibility. Technology continues to drive innovation in banana processing, with artificial intelligence and automation enhancing efficiency and reducing operational costs. AI-driven quality control systems detect imperfections with greater precision than human inspectors, ensuring that only the best bananas make it to market. Machine learning algorithms analyze production data in real time, identifying trends that allow factories to optimize processing speeds, reduce waste, and improve overall efficiency. Robotics are increasingly integrated into packaging lines, where they handle delicate bananas with minimal risk of damage. As the demand for banana-based products grows, factories are expanding their product lines to cater to evolving consumer preferences. Beyond traditional banana puree, chips, and dried fruit, manufacturers are introducing new items such as banana flour, freeze-dried banana powder, and protein-enriched banana-based snacks. These innovations cater to health-conscious consumers seeking natural, minimally processed foods with high nutritional value. From plantation to processing facility to final distribution, banana production is a seamless operation that combines agricultural expertise, advanced manufacturing techniques, and sustainable practices. The ability to efficiently process and transport bananas on a massive scale ensures that consumers worldwide continue to enjoy this beloved fruit in various forms. Whether eaten fresh, blended into a smoothie, baked into goods, or enjoyed as a crispy snack, bananas remain one of the most versatile and widely consumed fruits globally. Once banana products are processed and packaged, they must be distributed efficiently to reach retailers, food manufacturers, and consumers worldwide. For fresh bananas, the final stage of ripening takes place in specialized ripening centers located near major markets. These centers use advanced ethylene gas chambers to trigger the banana's natural ripening process, ensuring they develop the ideal color, texture, and sweetness before being shipped to grocery stores. Temperature and humidity are carefully controlled during this stage, preventing premature spoilage while allowing for even ripening across each batch. Once the bananas reach their optimal ripeness, they are packed into ventilated boxes and loaded onto temperature-controlled trucks for final distribution. Processed banana products such as banana chips, dried bananas, and banana puree follow a slightly different logistics pathway. Since these products have a longer shelf life than fresh bananas, they are stored in climate-controlled warehouses before being shipped to retailers, wholesalers, and food manufacturers. Advanced inventory tracking systems monitor stock levels in real time, ensuring that shipments are distributed efficiently while minimizing excess inventory and storage costs. Many factories have implemented just-in-time manufacturing strategies, producing banana-based products based on real-time demand forecasts to reduce overproduction and food waste. Banana puree, in particular, is a key ingredient in a wide range of food products, including baby food, yogurts, smoothies, baked goods, and sauces. Bulk shipments of banana puree are transported in large aseptic containers or barrels, which keep the product sterile and fresh without the need for refrigeration. These containers are shipped directly to food manufacturing plants, where the puree is incorporated into various recipes. Some food companies also receive freeze-dried banana powder, which can be easily rehydrated and used in an assortment of food and beverage applications. Dried bananas and banana chips are transported in airtight packaging that preserves their crunch and prevents moisture absorption. Retailers often display these products alongside other dried fruit snacks, appealing to health-conscious consumers looking for natural, convenient snack options. The packaging of banana chips is designed to be lightweight yet durable, ensuring that the chips remain intact during shipping and storage. Many brands use nitrogen flushing to replace oxygen inside the packaging, which helps prevent oxidation and extends shelf life. One of the biggest challenges in banana production is maintaining sustainability and ethical sourcing. Given the vast scale of banana cultivation and processing, the industry has faced increasing scrutiny regarding environmental impact, labor conditions, and fair trade practices. To address these concerns, many banana processing facilities have adopted sustainable sourcing policies, ensuring that bananas are grown using environmentally friendly agricultural methods. These initiatives include reducing pesticide use, conserving water through efficient irrigation techniques, and promoting biodiversity in banana plantations. Fair trade certification has also become a key factor in the banana industry,